Good morning, friends. In this video lecture, let us discuss about the aerodynamic center and the center of pressure in detail. Also, this is the continuation of the previous lecture that we have seen about the basics of aerodynamics, especially how the moment is will be acting at the center, that means leading edge, and also at the aerodynamic center. So that is what we have seen in the previous class. So in this class, let us see some of the important points about the aerodynamic center and the center of pressure, and also let us get the relationship between aerodynamic center and the center of pressure. So first, let us see some of the important points. The important point is first thing is, in both the cases we can write it is the point on the it is the point on the it is the point on the chord of an aerofoil. Chord of an aerofoil. Same thing suits for here also. That means here also we can write it is the point on the chord of an aerofoil. So here also we can write it is the point on the chord of an aerofoil. And the second point is here we can write it is this is a fixed point. Aerodynamic center is the fixed point. It is the fixed point, and whereas it is a movable point. Fixed point and movable point. Movable point with the angle of attack. So we can just that is what so angle of attack, it is subjected to the center of pressure position is subjected to the angle of attack. So this is the center of pressure, and here it is, this is the aerodynamic center. So and then another important point is this point is fixed. That means this is independent of the this point is independent of the angle of attack, and this is depends on the angle of attack. So that's what even in the previous point also we have mentioned, it is a movable point with the angle of attack. And next another important point is the pitching moment or pitching moment. Moment is independent of the angle of attack. Here moment is 0. So whenever we say moment, this is very important, pitching moment. Generally that is what we consider in the aerodynamics or in the aerodynamic analysis. And why do we consider as the fixed point, that means aerodynamic center as the fixed point? Because for analyzing purpose we need a fixed point. So if the point is keep moving, then analysis cannot be done. That is a point, that is a reason. So here that means whatever the forces are acting at the center of pressure, that forces only are shifted to the aerodynamic center. So that is one thing. So when we are shifting the forces to the aerodynamic center, then that is creating that causes the moment. That moment only we call it as pitching moment or moment about aerodynamic center. So this we can call it as moment about aerodynamic center. So this is, and now so these are the important points. I think these points are common, generally available everywhere. Now let's find the relationship between aerodynamic center and the center of pressure. So the relationship we can just have it with respect to the that means taking the moment about leading edge. So first let us take the moment about the leading edge, and then we can find the relationship. So for taking the moment about leading edge, let me just consider the moment is leading edge. So here also the moment is, let us consider the moment about leading edge. So now we have to find the relationship. Let me say that summation of the moment equal to 0. Even here also, instead of saying CMAC, this is MAC only. So moment about aerodynamic center. Summation of the moment 0, and here also the summation of the moment equal to 0. So now let's write the summation of the moment. So moment about leading edge, taking moment about leading edge, so moment about leading edge equal to this is clockwise positive, then this MAC is negative, anti-clockwise, so MAC, then minus, due to this aerodynamic forces there will be a moment. So that is, from this figure we can understand that lift will be L cos alpha plus the drag also will be subjected to an angle, so that is sin theta. So that will be, both will be added, so both will be in the same sign convention. So d sin alpha, this is equal to 0 in this case. So similarly with respect to the here we can write the summation of the moment. So leading summation moment about leading edge equal to then minus when we are taking the moment, then we have forgotten one thing, that this is a force into horizontal distance, vertical force into horizontal distance only moment. So here we have to multiply with the distance. So this distance is nothing but XAC, and here it is XAP. So here I have to write XAC equal to 0. Similarly here with respect to here, L cos alpha plus d sin alpha into XCP equal to 0. So this is what summation of the moment in both the cases. Summation of the moment in the aerodynamic center and summation of the moment in the center of pressure case. So now, because both are okay, leading edge is this, now I can equate. So we can equate the with respect to the aerodynamic center, that means with respect to the leading edge. So I can write moment about leading edge equal to MAC plus this is L cos plus d sin alpha into XAC. This also will be equal to, here I can equate L cos plus d sin into XCP. So this is what. So moment about leading edge in the case of aerodynamic center and in the case of center of pressure. Now let's divide let's divide it by half rho v square SC. So if you are dividing this whole equation by this, then we will be getting Cm leading edge equal to CMAC plus CL cos alpha plus CD sin alpha into XAC. This, in this case the C will be remaining, so that we can put it here. Similarly, that is equal to CL cos alpha plus CD sin alpha into XCP by C. So here also we will be having C. So now so after dividing by half rho v square, we are getting this relationship. Now let's further simplify. Let us take these two. That means if I consider these two equation, then CMAC if we consider these two equation, then we will be getting the relationship between aerodynamic center and center of pressure. So CMAC plus CL cos alpha plus CD sin alpha into XAC by C, that is equal to CL cos alpha plus CD sin alpha into XCP by C. So now we can find this divide by CL cos alpha by CD sin alpha both side. So dividing by CL cos alpha plus CD sin alpha, then we'll be getting XAC. That means here CMAC by whole divided by CL cos alpha plus CD sin alpha plus XAC by C, that is equal to this side. If we are dividing, then we will be getting XCP by C. So this is a relationship finally we are getting. Then this further can be simplified. by considering alpha. If alpha is very small, then we can say that cos alpha approximately equal to 1, then sin alpha approximately equal to 0. So now by taking this condition and then substituting here, then further we will be getting this relationship. Means XCP by C equal to XAC by C plus CMAC by CL, because cos alpha 1, this sin alpha is approximately equal to 0, so this term will get eliminated and only CL will be remaining. So XCP by C equal to XAC by C plus CMAC by C. So this is the final relationship we are getting. This relationship is we have to understand one thing, that by taking the actual sign convention of the moment, okay, that we have included, because in most of the books what this derivation would have been XCP by C equal to XAC by C minus CMAC by CL. So in most of the book this is okay, that is what I would have been given, but because I have taken the actual sign convention when I am just writing the summation of the moment equal to 0. So that means clockwise is positive, anti-clockwise is negative. So based on that this is. So XCP by C, actually it is greater than the XAC by C. That's what from the figure also we can understand. From this figure we can see that XAC is smaller than XCP. So that this relationship proves that, because XAC you can just, because XAC by C plus CMAC, what is the CMAC value? So that is generally that value will be located at 25% of the chord. So that is what we say. So that means pitching moment will be there at 25% of the chord, approximately, okay, 25% of the chord. So because of that, by adding that value and then adding that value with the XAC by C location, then finally we are getting XCP by C. So here we have to note down. So we have taken the actual sign convention. So CMAC, actually it is that means clockwise is positive, anti-clockwise is negative. So here one more thing we can see, because this is okay here, since the center of pressure is forward, that means not forward, backward of the aerofoil, backward of the pitching that aerodynamic center. Here the center of pressure is backward. That means let us say that this position, this is forward and this is backward. So this is forward, and here if the center of pressure moves this side, it is backward. So here it is, we can write it as backward, and here if this side is forward. So suppose if the center of pressure is moves towards the aerodynamic center, so that we say that it is moving okay, that means forward of the aerodynamic center, or okay, if it is moving towards the trailing edge, then it is backward of the aerodynamic center. So now with respect to this forward and backward position, if the center of pressure is backward of the aerodynamic center, then this will be creating the anti-clockwise movement. So that is what we have to understand. If it is backward of the if the center of pressure is backward of the aerodynamic center, then this will be creating anti-clockwise movement. So that is generally taken as negative. and if it is forward, if the center of pressure is ahead of the aerodynamic center, then that will be creating clockwise movement. So that is what we have to understand. So because center of pressure is not the fixed point, so it will be keep moving forward and backward, okay, backward on the chord of the aerofoil. So hope, I think this explanation is very clear about the center of pressure and also about the aerodynamic center, and also this relationship, okay, will be clear. I think so they should not have, people should not have a confusion, students should not have a confusion that in most of the books this will be given, this sign convention generally will be given as negative, but in that case what the CMAC they used to consider as negative. So negative and negative will become positive. But since I have taken the sign convention and the original sign convention is included in the CMAC, then that is why I am putting positive. So hope, I think this is clear. So we will see in the next class with some other important concept of the aerodynamics. Thank you.